I'm going to show you a really quick and effective way of doing this question, and then I'm going to show you a much more modeled way, which is how I did it. And to be honest, still seeing like methods that are not as good is worthwhile. So the best way to do it is we're focused really on the number of people who played both basketball and football. So I'm going to call that B in the middle. And we're also given, well, we're also told that some play neither, so I'm going to call that N. I'm going to work in terms of these two things. So we're told that twice as many people played football as played neither. So that means the number who played football is actually going to be 2n. And that means that it must be 2n overall here. And so this is actually 2n minus b. So that's football. And then for basketball, twice as many played basketball as played football. So 4n must have played basketball and this must be 4n minus b. And what we managed to do is just write the Venn diagram in terms of these two unknowns. Now we're given one other piece of information, and that is that when we add all these together, we get 30. So 4n minus b plus 2n minus b plus n must equal 30. Okay, combine the like terms, 7n minus b equals 30. And what we're interested in is the number who played both, so b. So rearrange that, so b is going to equal 7n minus 30. We actually have a Diophantine equation here, two unknowns, but they have to be integers. And in this case, they both have to be positive, and also the numbers inside here have to be positive as well. So let's take a look at some possibilities. N can't equal 1, for example, because then b would be negative. It would be a solution to the equation, but not to the actual problem. So to get a first possible solution, we're going to have 5. N is 5. If it's 4, we still get minus 2. But when n is 5, we've got 35 minus 30. B is going to equal 5. Now, the fact that this is one of the options probably means that is going to be the answer. But let's just check, the other solutions. So if n is 6, we'd get 42 minus 30, we'd get 12. When n is 7, it would be 14, we get 19. And then when n is 8, we'd get 56, we'd get 26. And then we'd end up with b greater than 30, actually, so that's not going to work. The only thing is that okay? What happens? So 2n minus b, for example, when here would be 16 minus 26. This would be negative, so we can rule that one out. This one here, we'd get 14 minus 19. That would be negative. Here we'd actually get 12 minus 12. We'd get 0. Would that work? So we'd get 0. In the middle, we'd get 12. 4n minus b would be 12 here. And we get 6 here. So twice as many are playing football as neither still. It's just quite a strange solution, but I was just questioning it for a second. But that would actually work. And it would work as well, but that's not one of the options. It would work as well for 5. So here we would get 2n minus b is 5. We'd get 5 in the middle. We're going to get 15 here. And then we're going to get 5 here. So that works when b is equal to 5. So both of those are valid solutions. But to get back to the original thing, like there's only one of them actually as an answer. So it has to be this option here. So yeah, that's how we can do this question really quickly and effectively. Now, I'm going to show you another method for how to do this. It's not as good, but you might think, hey, I would never have thought to kind of use that approach and get it all in terms of B and N. So my second approach, whilst not as good, is still effective. It's actually how I did it. So, right, same sort of approach to start with. I'm going to go with B for both. This is basketball and this is football, and N for neither. Now, what I didn't realize is like, yeah, you can now effectively write these in terms of B and N. So I didn't do that. I actually instead went for F for football, and I'm going to go with K here for basketball because I've already used B for both. And then we are told that twice as many people play football as play neither. So I've got the number who play football is going to be B plus F. And actually that is going to equal 2n. Okay, I can write an equation down. This is what I mean by it. It's not quite as effective, but it's going to work out. And then four times, what was it? Sorry, twice as many people play basketball. That's K plus B as play football. So K plus B is then 2 times B plus F. Okay, so that's the second equation. And then a third equation, you can already see like how much more complicated this is that when we add them all up, K plus B plus F plus N is equal to 30. Now the approach is to essentially just a longer version of what I did right at the start. We're going to try and replace K and F we're going to put them in terms of B and N. So I'm going to multiply this one out. I've got K plus B. It's going to equal 2B plus 2F. Right, I'm now going to make K the subject. So K is going to equal B plus 2F. So I can replace this here by B plus 2F. Got rid of it. Okay, so that means that 2B, because I just combined them, plus 3F plus N is equal to 30. Then I can do the same up here because I can actually write F is equal to 2N minus B. So then 2B plus 3 lots of 2N minus B. And you can see, look, I've managed to eliminate it. It's just a longer process. And when I did it, I didn't even do it quite as well as this, but I did get to the answer. So 2B plus 6N minus 6, minus 3B plus N equals 30. And then we're left with 7N minus B equals 30. And from that point on, I'm actually exactly where I was here. So I could make B the subject, 7N minus 30, and go from there. So just an alternative approach, worth being aware of that if you don't spot this. But I think my lesson learned is try to use the information to write the Venn diagram in the most effective way possible, and then the answer will be achieved in the most efficient way.